Continuing to talk about center of mass calculations, we're going to go up another dimension. So we're going to be talking about volumes now. So we're going to find the center of mass of this volume here. And this volume is described as this region underneath y is equal to the square root of x. And it's bounded by x is equal to 1 and x is equal to 2 and the x-axis here. And what we're going to do is rotate this region about the x-axis. So we're going to end up with a volume. We're going to end up with a volume here. And our volume has a variable density, and that's represented by this density function up here. This Greek letter is rho. So given all of this information, why don't you pause the video and try to find the x, y, and z coordinates of the center of mass of this volume. All right, assuming that you've given it a go, we're going to start working on this x coordinate here, and we're going to see how far we get. So we have the x coordinate of our center of mass. We're going to get some definite integrals from a to b of, and then it's going to be x times dm, and then divided by definite integral from a to b of dm. Now, similar to all the other videos we've been working on, we need to figure out what dm is. So we're going to look at our density function. So this is rho, and rho is, this is probably how you've been introduced to density in the past, whether that be a science class or something, defining density as mass over volume. Mass over volume. Okay, and then when we look at the infinitesimals of these guys, we have that rho is equal to dm over dv. And then solving for dm, we have dm is equal to rho times dv. So let's substitute this in and see what we get for some integrals. So we have definite integral, we'll still keep it a to b for right now. And then we have x, and dm we found to be rho times dv. Rho times dv. Okay, and then we're going to divide by definite integral from a to b of rho dv. Rho dv. There we go. And now, what do we need to figure out? We already told rho. Rho is 2x squared. So again, we need to talk about dv. And similar to what we did in the last video, I mean, if I just were to strip away all of these center of mass calculations, all of that, and just ask you, okay, find the volume. Find the volume of this region spun around the x-axis. What would you do? And you say, okay, well, I have two methods to handle that. I could do some disk method. I could do some shell method. I could do all of these things. Now, really, we're going to come back to, okay, we actually need to calculate the volume in a specific way here, and that's going to be dictated by our density function. Specifically, when we rotate this guy about the x-axis, this region here, we'll get a volume that kind of looks like this as a cross-section. And on a cross-section like this, and this is kind of going to give it away, but that's fine. On a cross-section like this, when we look at this disk here, all across this disk for this given x value, all across this disk, this density function is telling us that we're constant across this whole disk here for this given x value. So when we have that and our density functions varying in the x direction, we're going to be using the disk method to calculate the volume of this. So this right here is going to be the disk method. We're going to use some disk method. Maybe that can be in blue. Let's make that in blue. This will be the disk method. And we know that's pi r squared. And in this case, this is going to be integrating with respect to x. So that's what we're going to fill in now. So let's do that. We're going to have a definite integral. Let's leave our limits of integration for a little bit. And we're going to have x times rho, which we said is 2x squared. 2x squared. And then dv we said is pi r squared. And what is r here? That's going to be this height. So that's going to be this y coordinate, but we want it in terms of x. So that's going to be the square root of x, and then squaring that whole thing. And then we're going to have a dx. Okay. And then in our denominator, we again have a definite integral. And filling in what we have 2x squared. And then we said dv again is going to be pi times the square root of x. And then that whole thing squared times dx. Now let's get our limits of integration. You can see we're integrating with respect to x. So we're going to be going from 1 to 2 here. Those are going to be our limits of integration, 1 to 2. And now we have our integrals. So now all we need to do is evaluate these guys. So let's see what we get. Again, pause the video, try to evaluate these. And what we're going to do, let's try to simplify these integrands. We see a pi in both of these. We can factor that out, and those will eventually cancel. But let's see, we're going to have pi. I'm just going to leave everything in white now. So you have pi times the definite integral from 1 to 2. And then it looks like if we were to simplify this, this would just be x here times x, so that's x squared times 2x squared. So that's 2x to the 4th dx. And then we're going to divide by the definite integral, and we factored another pi out. So we had pi times the definite integral from 1 to 2, and we're just going to have one less degree here on our x value. So this is going to be 2x cubed dx. Now, we can see our pi's cancel, and when we anti-differentiate and evaluate, what do we get? We're going to have 2/5 x to the 5th, evaluated at 1 and 2. That's a 2. And then over, we're going to have 1/2 x to the 4th, evaluated at 1 and 2. So let's see here. 2 to the 5th, that's 32. So we have 64/5. Just getting some lovely fractions in these last couple problems. And then we have minus 2/5. That's minus 2/5. And then denominator here, that's 16 over 2. So that's 8. So it's 8 minus 1/2. And then let's see, we get 62/5 in this numerator here. And then denominator 7/2. So that's going to be, well, that's 7 1/2. It's not 7/2. So that's going to be 15/2. 15/2. And then we flip this fraction, and let's see here. I'm kind of out of space. We'll write it just above. What do we get? We get 62 times 2, so that's 124. And then 15 times 5, that is 75. So just another lovely fraction coming out of here. But this is our x-coordinate. This is our x-coordinate for our center of mass. So this is x bar. And in the next video, we're going to talk about what the y and z coordinates of this center of mass are. But if you've already calculated them, again, you don't need to calculate them. We're going to talk about that in the next video. This is our center of mass. Our center of mass is going to be 124/75. And then the y and z coordinates are both going to be 0. And we'll talk about why that is in the next video.